So in this chapter, let us first discuss few things. What is the difference between gravity and gravitation?
Gravity
What
and
can be gravity and gravitation? What can be the difference between gravity and gravitation? Who can tell me? That's any idea? See, in my class, anyone wants to talk anything to me, please. Okay, switch on your mic and talk. Okay, there is no restriction for anything. We can discuss anything with related to the subjects in the class. I'm open
The,
to any kind of discussions. Yeah.
the gravity is different from gravitational
That I know.
force.
What can be the difference? Like, okay, see, let's see if there are two objects. Okay, this is the force between these two. We can talk it. We can call it as gravitation. All right. This is gravitation. You understand? And suppose this is our Earth. Okay. This is our Earth. The force which is exerted by the Earth on these two objects. Okay. This is what gravity. Understood the difference between these two? Okay. Suppose you and the person sitting nearby you, or suppose you and a car. Okay. Suppose you are standing near to a car. Suppose you standing near to any animal. Suppose you are standing to any other objects near to that. So there's a unbalanced force between you and that two or that object. Okay, which we can't see. For example, if you are standing near to an elephant. Okay, suppose you are standing near to an elephant. You and elephant, there is a force in between you and the elephant. Since the mass of the elephant is more than you, okay, or or you are not feeling that sensitivity of that force between you and the elephant, okay, it has not been seen. In the other case, let us say that if we wanted to lift an apple by hand, okay, if you wanted to lift an apple by hand, is it possible?
Yeah,
Is it possible?
yes, sir.
Okay, you can just lift it. But if you want to lift an elephant, what will happen?
The elephant will lift me and throw me.
So what happened? Size matters here. Simple, simple logic is what actually size matters. Okay,
Yes,
size matters. So Avantika, what we are learning today, Avantika, good morning. You didn't speak to me till now. Hi,
yes, sir.
hi. How are you?
Good. How are you, sir?
Good. Thank you so much. I'm happy to see you. Chalo. So we are discussing about gravitation. I said two difference between the gravity and gravitation. Did I tell you the two difference? The difference is what? Gravitation is nothing but like, let us see, this is object one and this is object two. Okay. The two objects. Let us see the two objects. There is an unbalanced force between these two objects. Okay. Size matters. So let's see M and M2. Okay. What I said? Mass 1, mass 2. In between these two objects, there is a force. That force is called gravitation. But these two objects, okay, staying back very close to Earth, or why Earth attracts this, but these two masses is because of gravity. So now, if anyone asks you what is the difference between gravity and gravitation, will you be able to tell? Okay. Gravitation is nothing but, come on, everybody, let's together say gravitation is what actually?
gravitation is the force acting between two objects in the
Two objects.
universe.
Gravity is nothing but the force attracted by the earth. Okay. Gravitation is force attracted by the earth. Gravitation is the force between two objects. Is that clear now? So we have a see, in physics what happens, any concept is connected to mathematics. Okay. Let's take, if we have to understand. See, I said always, I used to tell people that learning physics through mathematics. What is that? Learning physics through mathematics. You got me? You got me what I'm saying? Learning physics through mathematics. So what is learning physics through mathematics? Okay. let's see if there is a person here and this is Max. Okay. Hello. Okay. Another person is here and this is physics. Okay. Now I have a pulley here. As far as physics concerned, I have a pulley here. So let's see. This is physics, and I have a pulley here. This pulley I have connected to physics one end, another end I have connected to maths. Okay. All right. So through this pulley, okay, I have connected one end to physics, one end I have connected to maths. Okay. Now physics and maths. So both are, if you see that, like both are connected one to another. When without physics you can't live. Suppose you leave this pulley. Suppose you cut physics here. Okay. Maths will fall down. Suppose you cut maths here, physics will fall down. You got me what I'm saying? You understood? Let's say this is physics is one human and maths is another human. So maths human think that I have to pull down physics. So let me cut myself from here. Okay. So if maths thinks and cut this cable, okay, or wire, so physics will fall down, maths will also fall down. You got me what I'm saying? So let us connect the gravitational this gravitation. Okay, let's connect gravitation to gravitation to a formula F. We know F. What is F? Force. Am I right? Force proportional to m1 m2, okay, divided by what we can do? D square. What is D square? What is D square, my dears?
Distance between the two.
So let's see m1. Sorry, m1 and m2. Okay. Force by this to this. Force by this to this. Okay. Two objects attract each other. Okay, my dears. Okay. So D1, D2. Okay. D1, D2. That D2 I have taken here. Is that clear? Is that clear? Okay. Now M1, M2. Okay. Force proportional to mass 1, mass 2 divided by distance squared. Understood or not? Are you able to understand? Okay. Now
So
here.
what is D?
Which one?
What is D?
D is distance. Distance
M is
between
mass.
mass 1 and mass 2. Okay. This is mass 1. Let us see which one is mass 1. Mass 1 is, this is mass 1 and this is mass 2. Is that clear, my dear?
Yes.
So 2 mass and the distance is this. D square. Why D square? 2 distance. Okay. 2 distance. Mass 1 to mass 2, mass 2 to mass 1. Is that clear? Is that clear? What we are learning today?
Gravitation.
So what is the difference between gravitation and gravity?
Gravitation is the force acting between two objects.
That is why
Gravity
we
is
are
the
doing this.
force by
Okay.
the earth.
By the force attracted or force exerted by the earth. Gravity is nothing but force exerted by the earth. Is that clear to all of you? Okay. Gravitation is two forces between two mass 1 and mass 2. So mass 1 is an object, mass 2 is an object. This force between these two objects. Okay, which means what is told? Okay, the concept is told like this. Now I will write what is the concept. The concept is nothing but, okay, this probably if you want you can note it down, the concept. Okay, universal law of gravitation. Law of gravitation. Okay, what is universal law of gravitation? It says every object every object in the universe. Is the board visible to all of you? Is it visible?
Yes, sir.
So please do write the universal law of gravitation. In every exam, it is asked to explain universal law of gravitation. Okay, what is universal law of gravitation, which I am going to write here. So I am writing here, every object in the universe attracts every other objects, okay, with a force, which is proportional to the product of their masses and inversely proportional to the square of the distance, to the square of the distance
Between them.
distance between them. Is it clear now? This is the concept of universal law of gravitation. So here size matters. Okay, their masses. Size matters. You understood? See, we are able to lift an apple with a free hand, but we cannot lift an elephant. Am I right? Because the gravitational force exerted by the earth on the apple is lesser than the mass of you, so that you are able to lift the apple. But if you wanted to lift an elephant, what happens? The gravitational force exerted by the earth on the elephant is what actually more than the apple. Am I right, my dears? Isn't it? Understood this particular area? Okay. So now we have understood, and what is the mathematical expression, or how it is connected with mathematical? F is equal to F is equal to
proportional to
F is equal to, or F is F
pressure into
proportional.
area. F
Okay.
is proportional to
F is proportional to
M1
M1
M1,
by
M2
D square.
by D
M2
square.
by D square. Now this proportional, okay, I am changing into F is equal to, okay, to a constant value. F is equal to, okay, what I'm doing, that proportional I'm changing, and I'm bringing a universal gravity here. Okay, universal gravity constant. This is nothing but F is equal to G M1 M2 divided by D square. What is this G?
gravity,
It is nothing but, okay, this G is nothing but, okay,
gravitational force,
we can take it as universal, okay, gravitational constant.
Oh,
Okay, universal gravitational constant. And since it is a universal gravitational constant, you need to understand a value by X, not me. Someone has found out a value for this. This value is also there, and this value for universal gravitational constant is that which you need to understand and you need to remember is 6.67, okay, into 10 to the power minus 11, okay, and the SI unit is Newton meter square by kg square. My dears, remember this value. The value for G is nothing but 6.67 into 10 to the power minus 11 Newton meter square kg square. Okay, What is the SI unit? Newton meter square and kg square. So we need to understand what is this Newton meter square. Am I right? Do we need to understand? Should we? Should we understand or you know?
Yes.
Do you know what is Newton meter square? How it has come? This value is okay. Universal gravitational constant is given a value. Okay, this value is okay. There is a value is given 6.67 into 10 to the power minus 11. This value will be in all the numericals. This value will be asked. Without this understanding this value, we cannot do the numericals of gravitation chapter. So what is the value I said? G is what? This big G is what? Universal.
6.6. Universal
Very good, my dear.
gravitational constant.
Very good. Very good. Universal gravitational constant and the value is 6.67 into 10 to the power minus 11. Okay? Yes or no?
Sir, what is after 10 to the power minus 11?
Yes. What are you asking, my dear?
What is after 10 to the power minus 11?
That's what I asked. Newton meter square by kg square. So the value is taken. See, any quantity in physics, there is a SI unit. Am I right? For any quantity, there is a SI unit. So the SI unit is what actually here? Newton meter square by kg square. Now I'll tell you how this Newton meter square and kg square has come. So this part have you all written? Himani, I can't see you, dear.
Yes, sir.
Himani, yeah, keep your camera on. Thank you so much. All right. So here, this is copied. Is this copied? यार बोलो ना yes or no.
Yes,
Copied
sir.
or not? ठीक है. So let's see what is this Newton meter square. Okay. So we know that F is equal to G. Tell me M1 M2 divided by D square. Okay, D square. All right. So here F is what? Force. Yes or no? Hello. F is force. Yes or no?
Yes, sir.
G is what?
Gravitation.
Universal gravitational constant. Am I right? M1 M2 is what actually? Hello. M1 M2 is what? Mass mass of two objects. Am I right? Am I right?
Yes.
Okay. So can we write like G equal to, okay, force into D square by M1 M2. Yes or no? D square is what I said. Okay. Distance
square.
there is a force in between these two distance M1 M2 there is a force applied. Okay, object 1 and object 2 is applied a force into D square, okay, divided by M1 M2. So we can we take now the force SI unit is what? SI unit of force is what?
Newton meter square by kg.
Newton. So distance SI unit can we take meter?
Yes, sir.
Newton meter square. And mass, what is the SI unit? Kg square.
kg.
Two masses are there, so kg square. Understood now?
Yes, sir. Yes, sir.
Now how Newton meter square and kg square has come? This is the derivation, okay? Newton meter square and kg square. Are you able to understand or not? Now let me know. Let me know if you can't understand. All right. So in this F is equal to G M1 M2. M1 is what actually? Who can tell me? M1 is mass 1. M2 is mass 2 divided by D square. Am I right?
Yes, sir.
Yes or no? Correct. So what is the value of G?
Gravitational unit.
Okay, right. Now, can I rub this? Now,
Yes, sir.
slowly I'll change this formula a little more, okay? Little more better way I'll change the formula. Which formula? This one I'm going to change. Which one? This one.
False.
All right? Which I'll just round it off here. This formula going to take a slight change. As far as this currently this slide concerned till this part, are you able to understand or not? Understood. Okay. So here let me just change this to a little bit different way. Now let us see what we are learning here. Gravitation. Am I right? Yes or no? When we are learning gravitation, we need to understand gravity, or we need to connect the formula to gravity. Yes or no, my dear? Yes or no? You're not
Yes.
telling me. Okay. You're not telling me yes or no. Suppose you have a mass. Okay. Now you are keeping a stone on this mass, above this mass. Okay. You have big mass. Let us consider if this is Earth. What is this? Earth. Yes or no? Yes or no?
Yes, sir.
Yes, sir.
So since suppose you are keeping a stone here, this is a stone on the surface of the mass, on the surface of the Earth. Okay. Now, what will be the what do you call force of attraction of this stone towards Earth? Calculate the force of attraction what will be the force of attraction? Since it is kept on the Earth, there will not be any force. Will there be any force? Or do we think, or is there any gravitational force still applied by the Earth? Gravity is there. Okay, now we are keeping a stone on the surface of the Earth. Okay. Do you think still the stone is experiencing a gravity from the Earth? Or
I think so.
gravitational force from the Earth? Do you
Yes,
think?
I think. Yeah.
If yes, okay, where that exactly, from where that force is coming exactly towards that stone? Is it from the surface of the Earth?
From the center of the earth.
Wonderful. From the center of the Earth. So here, let's take it is coming from the center of Earth. So this distance, can we call it as R?
Yes, sir.
Can we call it as R?
Yes.
Yes or no? Since
Yes,
I'm
sir.
calling this R as R, I'm taking this equation as F is equal to Gm M2 or M1. Okay. Gm M1 by R square. Can I write like this? Okay. What
Why
is
R
this?
square, sir?
This one is this mass. Okay. M1 is the mass of this stone. Okay. R square is the radiance. Yes or no? Yes or no, my dears?
Yes, sir.
Understood now how R square has come? Arthur, are you able to understand?
Yes, sir.
Okay. So now we have this particular area we can consider as acceleration due to due to due to due to
Gravity.
gravity. Okay. Acceleration due to gravity. So we will write acceleration due to gravity mean by, we can write like this. What we will write? We will write G equal to Gm by R square. Okay. Because this earth mass is gone here. G is, we already know one value. So G has gone there, and G universal constant value. G is, this big G is the universal constant value of gravitation and the mass of the stone divided by r square. Is that clear? Is that clear, my dears? What is small g value? The value of small g is how much? Gravitational acceleration due to gravity 9.8
8.
meter
Didn't
per.
it change to 10 or is it 10 or 9.8?
It is 9.8, my dear. It is exact value is 9.8, but for numerical calculations we can take it as 10. There is nothing wrong. Okay. When you do numerical for, if you simplify with 9.8, it will be a trouble. All right. So what we can do is that we can use 10 there. Nothing wrong. Okay. Is that clear? Are we clear till this point?
Yes.
If you tell S or S to me only, I have to go forward.
Yes, sir.
Yes.
Now, there is something interesting which we need to understand is gravitation is to do something with solar system. Any idea? Okay. So what happens to, see, we understand mass 1, mass 2 are having some unbalanced force or force of attraction in between them. Okay. Then why do you think, or do you think, if this is the case, why two objects are not colliding each other? Gravitation says that there is a force between two objects. Am I right? What we are learning is gravitation, and gravitation tells that between two masses there is a force. Okay, unbalanced force which we can't see, or something we are observing or we are able to experience somewhere. So there is a force between two objects. My pen on one hand, my hand on the other side. So my pen and my hand is having one attraction. The pen is attracting the hand, hand is attracting the pen. So there is a force between these two objects. Now, in that case, why Earth and Moon is not colliding, or why Earth and Sun is not colliding, or why Earth and Jupiter is not colliding? Any idea? Any idea? Suppose you are going on road, actually one car should come and collide with you, right? If that is the case. Yes or no? Yes or no? Right. So let us understand.
Yes,
there is something here which we need to understand in gravitation chapter. Something best to understand is solar system. There's a person called a person named P-T-O-L-E-M-Y. Okay. Told me. All right. This person who lived in 140 AD, okay, have told us a theory called geocentric theory. What is that? Geocentric theory. Now I will teach you 2 to 3 theories here, which is very, very important. Okay, as far as physics concerned, understand what is geocentric theory. All right. Hope all of you are with me. My dears, all of you are with me.
Yes, sir.
Okay.
yes, sir.
So we have to understand here a geocentric theory. So do we need to understand what is geocentric theory? Do we need to understand or not? Okay. Told me, a scientist have told to the world that Earth is at the center and all other planets are revolving the Earth. What did he say? What did he say? He said to the world that Sun is not at the center, which is not identified. Okay. In the year of 140 AD, told me, okay, this person, T-O-L-E-M-Y, told me, a scientist have told, Earth is at the center and all other planets are revolving the Earth. This is called geocentric theory. What is that? What is geocentric theory mean by? Earth is at the center, all other planets are revolving the Earth, which is nothing but geocentric theory informed by a scientist called Ptolemy. Are you all with me now? Okay. Now, can I rub this? Okay. Do we agree that? Did we agree that? Geocentric theory?
No.
No. How we will not, or how we have not agreed this? Okay. You would have heard about this name. I am sure you would have heard about this scientist name. I'm going to tell you a scientist name here. Okay. Nicholas Copernicus. Heard about Nicholas Copernicus? No. Understand about him. He was living in 1543. Okay. This person told heliocentric theory. What is that? Heliocentric theory. What is this heliocentric theory? Sun at center, all planets revolving sun. What did he say? What is this theory is all about? Heliocentric theory. First one was what?
Geocentric theory.
Geocentric theory, heliocentric theory. Now, heliocentric theory is told us that, okay, so you can imagine from 140 to the gap, like, okay, 140 to this gap, 1543 years, people believed, okay, people believed Earth is at the center, all other planets are revolving the Earth. Geocentric theory. But at the end of 1543, Copernicus, a scientist, have come and told that heliocentric theory is the best, or this is the actual scenario where sun is at the center and planets are revolving, all other planets are revolving sun. Now, why do we believe this? My dears, let me know why we have to believe this. Have you ever seen that, like, have you been to space anytime and checking that is it correct? Still we are believing heliocentric images. How trustful is images nowadays? Because nowadays the digital era is that much, like, morphing, that problem, this problem, images, this thing, and so many conditions. So how do we rely on images? How can we trust images? No, why do you believe if someone has told you sun is at the center, all other planets are revolving the sun? Why we should believe? That is what it is, heliocentric theory. Heliocentric theory is told by whom? Who was told this? Who was told this? Nicholas Copernicus.
Oh.
Okay. Now, why should I believe this? No idea. Okay. All right. Now, what has happened? After him, one more person has come. His name is, okay, what is his name is Tycho, Tycho Brahe, in the year of 1588. Okay. See, we have a tendency, any human being, that if somebody tells something to us, we don't believe unless until we see it with our eyes or we touch and feel it. We never believe it. Do you believe? Do you believe 50-50%? If somebody tells you something, okay, this is what has happened, okay, today something is happening like this, tomorrow something is going to happen like this, or this is what the product is all about like this, I've already seen it. So how many of you believe it? Difficult? All right. So this person came, Tycho Brahe, in the year of 1588, whereas Copernicus told us 1543. Okay. This person has come 1588 and he said moon at center. What did he say? He says what? Moon is at the center and all of the planets are revolving the moon. This system is nothing but called, okay, Tychonic system. What is this? Tychonic system. So three system as of now you have learned. What are the three system? First one. Who are noted down? First one was geocentric theory.
Geocentric and then
Geocentric
heliocentric.
theory, which means
Heliocentric.
Earth is in the center.
Now we are at
Moon is in the
Tychonic
center.
system. Tychonic system tells us what actually? Moon is at the center and all other planets are revolving the moon. Depend the switch on your camera. Okay, this is in the year of 1588. So who said geocentric theory? What is the scientist name?
Ptolemy.
Ptolemy. And heliocentric theory? Heliocentric theory?
Nicholas Copernicus.
Wonderful. And Tychonics has come. Now, okay, Tychonics is also rejected. First, geocentric is rejected by Nicholas Copernicus. Nicholas Copernicus is rejected by Tycho Brahe, okay, who has come after Nicholas Copernicus. And Tycho Brahe is also rejected. Okay, who is rejected him? Who could be? Who could be? Who can reject?
Galileo.
Ah, very good. Super. Galileo. Am I right? Galileo. In the year of 1609. Why did he reject it? Tell me why he would have rejected the Tychonic system?
Telescope.
Wonderful. Yeah. So he identified the telescope. Now, after identifying the telescope, he has identified, okay, Copernicus. Okay, Copernicus is correct. Copernicus is correct. Why? Because of the invention of telescope. Now we believe because we are able to see it. Okay, after developing the telescope, Galileo has told that to the world that heliocentric theory is the perfect one, whereas you should believe that Copernicus is an absolute scientist on this area who have identified that sun is at the center, all other planets are revolving, okay, revolving the sun. Why we are learning this? Because we have Newton said, okay, between two objects there is a force. If in that case, why do you think that planets are not colliding each other? We are going to reach that particular area. Okay, we are learning what topic today? Gravitation. So what is the value of G? Gravitational constant value. G is equal to 6 into, or what is the value of G? What did I tell you? G equal to 6.67 into 10 to the power
11.
minus 11 Newtons meter square kg square.
Gram.
Please don't forget this value. Till your 12th standard, beyond that, if you learn engineering or any other course, G value is there in the universe, and that you have to study along with this gravity chapter. Gravitation chapter is there till 12th standard. I believe in many board, whether it is IB or ICSE, CBSE, any board, gravitational chapter and current electricity kind of chapter is inevitable. Okay. So, what is the value of G here? G equal to 6.67 into 10 to the power minus 11. Three theories: geocentric theories, heliocentric theory, Tychonic system, and final Galileo. Is that clear, my dears? Is that clear till this point? Okay. Galileo has found out a telescope, and telescope was the proof for, okay, proof for what? Yes, heliocentric theory is correct. Now, I said in the first class of physics that there are three fathers for physics. Who are all they? Who are the three fathers for physics?
Galileo,
Galileo,
Newton,
Newton,
one more guy.
and the very famous, well-known
His Einstein.
Albert Einstein. Okay. So three people. So these three people have done major contribution to physics. Now from here, now I stopped where I stopped. Galileo has identified heliocentric theory is correct. Perfect, because I have identified, that is Galileo has identified telescope and told to the world this is the perfect theory of, or the system of solar, okay, where sun is at the center, all other planets are revolving the sun. Okay. Now there's a proof, that is the proof is nothing but telescope. When this is identified, now we have to identify why planets are not colliding. For this, another person has come. His name is Kepler. What is his name? Kepler. What I'm going to tell you, the name is, his name is Kepler. Okay. This fellow has nothing but law of planetary motion. See, gravity, Newton is best. Okay, gravity, gravitation, Newton is done so many activities just because of that apple fell onto his head. Okay, he has done so many researches behind it, and he has identified that there is a gravitational value, there is a mass on Earth, and there is a radiance of Earth, and below, in between there is a relationship, and so many things he had identified. But who will find out what is there on the solar system? That is this fellow. What is his name? Kepler's planetary motion. Okay, Newton may be best finding out any motion or any changes what is there in between any object which is traveling or which is kept on the earth. Okay, the gravitational force and motion force, everything is Newton. Okay, but what has happened to the planetary motion? Will that be Newton's identifications of gravitational force? Will it work in the planets? Will it work when it comes to planets? Okay, someone has to identify that. Am I right? So Kepler's law of planetary motion. Okay, with this, I'll give you 5 minutes break. Go for 5 minutes break and come back, and we'll learn the balance of it. ठीक है ना?
Thank you, sir.
Okay.
Thank you.
One of the where is everyone? Okay. Daksh,
Yes, sir.
others?
Others?
Okay. Now, till now, whatever we have learned, we will see through a presentation. Okay, I have a PPT which I will show you whatever we have learned so far. Okay, to go for better revision, let us understand through that PPT. All right. Well, share your PPT. Is it visible? I'm asking, is this presentation visible? Okay.
Yes.
So,
Yes, sir.
are you all with me? Yeah.
Yes.
So we have few things which will let us understand, and so what is his name? Johannes Kepler. What I said about Kepler? What
He
I
said
told
that
you? What I
everything
told you?
revolves around Earth.
A little more louder. Planetary
said
From the
motion.
laws of
Planet. Yeah.
Laws of planetary motion. Okay. Now we have two guys here. So one is already I told you that it is Isaac Newton, and he was the pillar behind gravity and gravitation, and whatever he did, which was according to the Earth and the conditions of the Earth. Now, two members. Okay. Gravitation. Now we'll go through these two members. All right. Who are all the two members? Isaac Newton and Kepler. So, do you see? Are you able to see the picture and are you able to read this? Whatever I have like brought here, are you able to read that? This apple tree is a direct descendant of the tree under which Isaac Newton is so and so, so and so. Okay, ठीक है ना? All right. So apple falls down, and this many laws have come. What are the laws have come? Can you tell
So
me
where
what
is
are the
it?
laws are here?
So where's the
Sorry,
tree? Where's the tree?
this is the tree. This is that tree.
Where is it, sir?
Where it can be.
Where? I don't know. That's all.
I am not sure about it. I got a picture of it, but I need to understand where it is. No idea. Okay. So because of that incident, we have, and I'm not sure about how much percentage is sure here. Okay, how much percentage it is sure of this tree here. But someone is told, and this is what the tree. So gravitational force of or gravity, Newton's law of gravitation, properties of gravitational force, universal gravitational constant, Kepler's law of planetary motion, Newton's first law and second law of gravitation, free fall, acceleration due to gravity, equation of vertical motion, mass and weight, thrust and pressure, pressure in fluid and buoyancy, and Archimedes principle, principles of flotation, density and relative density. So In this chapter, we are going to see 15 topics. That 15 topics are here. Would you like to note down what are the topics of gravitation?
So
Would
what
you be
is the
interested?
first thing? We can't read the first.
You can read, you can't see.
Only the first one. The second is right.
Gravitational force and gravity. Gravitational force and first one is gravitational force and gravity that we have already seen now. Okay. Newton's universal law of gravitation also we have seen now. And properties of gravitational force also I told you a little bit. Universal gravitational constant also I told you. Till 4 point I have given you some briefing. Am I correct? Now we have stopped with Kepler's law of planetary motion, which we have discussed. We haven't discussed. So this is the 15 area which we need to understand. Do you want to write this? I'm asking you. If okay, please understand
Yes.
gravitation chapter 15 main topics. The main topics of gravitation chapter. Are you penning down fast?
Yes, sir.
Yeah, do it. 1, 2, 3, 4, 5. Hope all are writing. These many interesting topics are there in gravitation chapter. Very each and every topic interesting and a little excited one to another. Commonly, we know what is mass, we know what is pressure, we know equations, and we know motion, we know acceleration, but there is something different. Something different in this. Completed?
No, sir.
Aditya, are you writing? Aditya M. Is Aditya writing? I could see if you are writing. Have you ever heard about Archimedes anywhere?
Yes, sir.
Where you heard about him?
Buoyancy.
Principle part.
Buoyancy. So you learned buoyancy, so you heard about Archimedes. Very good. ठीक है ना? So next, can I go to the next page? Shall we?
One moment.
Okay, ठीक है. कोई बात नहीं, लिखो. Time for you. Hope all of you returned. Done? Okay. All right. Moving to the next page. So gravitational force of the earth or gravity. So earth is here. Are able to see earth? Okay. A force is attracted to earth. Okay. A force is necessary to produce motion in a body. First statement. Okay. Which we have learned already in lesser classes 800 or some other topics you would already learn. Force is necessary to produce a motion in a body. Is it true or not? Yes. Okay. A body is dropped from a height falls towards earth. It indicates that the Earth exerts a force of attraction called gravity on the body. So, do you have a proper definition for gravitation, gravity on board gravity? Okay, did you get a proper definition? What is that? A body dropped from a height falls towards the earth. It indicates that earth exerts a force of attraction called gravity on the body. Is this part is clear to you? Is this clear? ठीक है ना? Next one. In fact, the earth attracts all the object towards its center. Earth attracts all the object towards its center. Where is the center? Is it on the surface of the earth?
Inner core.
Is it on the surface of the earth, the center?
No, sir. Inside.
Okay. All right. So inside, okay, it is other from where the center, the earth attracts the entire object towards it. The force with which the earth pulls the object towards it is called the gravitational force of the earth or gravity. Are you clear?
Yes.
What is that? The force with which the earth pulls the object towards it is called. So gravitational force means what? The force of the earth. Gravitational force is the force exerted by the earth. The gravitational force between the sun and the earth keeps the earth in the uniform circular motion around the sun. Now, why planetary motion we have not discussed. Kepler we will come back. But in between, there is a gravitational force. This force makes the sun and earth stay away. Okay? This force making the sun and the earth stay away. Gravitational force of earth or gravity is responsible for holding the atmosphere above the earth. Okay? What is happening? Gravitation is or gravity is responsible for a few things. Okay, I'll tell you which are all the things. Gravity is by gravity, through gravity it is affected. First thing is holding the atmosphere above the earth. Second thing, for the rain falling on the earth. Okay? Second thing, for the rain falling on the earth. Third thing is what? Flow of water in the rivers. Okay? Because of gravity. For keeping us firmly on the earth. Am I right? ठीक है ना? The revolution of moon around the earth, etc. Because of gravity, only the moon is taking a revolution. The gravitational force between the earth and the moon causes tides in the sea. Think why tides are high during full moon and new moon day. Tell me. You think and tell me. Why this can be? Why this is? You understood what is tide mean by? What is
Yes,
tide
sir.
mean?
The
What-
waves.
so- waves.
Yes.
High waves and low. High pressure waves and low pressure waves, right? Yes or no, my dear?
Yes, sir.
Okay. So what it could be? What is this has to do with gravity? Okay. Spring tides and neap tides. Two types. Okay. What are the two types? Spring and neap. Okay. Hello. See this? Okay, this picture. I've just brought some graphical representation of it. Let's see. Some picture representation. Okay. Now, the facts about lunar tides. Okay, optional in reading I've given. The gravitational force of the moon is 1/10 millionth of that of Earth. Okay. 1/10 millionth that of the Earth, which I'll teach you later. But when you combine other forces such as Earth's centrifugal force created by its spin, you get tides. What is centrifugal force and centripetal force? Any idea? We will learn. Don't worry. Sun's gravitational force on the Earth is 46% of that moon, making the moon the single most important factor for the creation of tides. Then sun's gravity also produces tides, but since the force are smaller as compared to the moon, the effects are greatly decreased. They are not caused by the direct pull of the moon's gravity. The moon is pulling towards on the water, while the earth is pulling downward, slightly advantage to the moon, and thus we have tides. Now, whenever the moon, earth, and sun are aligned, the gravitational pull of the sun adds to that moon, causing maximum tides. This all we'll learn detailedly. Okay. When the moon is at first quarter or last quarter, okay, phase, meaning that it is located at the right angles of the earth-sun line. Okay, the sun and moon interface with each other in producing tidal bulges, and tides are generally weaker. These are called neap tides. So understood, neap tide is what? Hope you are able to understand what is neap tides. Okay.
Yes.
Okay. If you want to note it down, you can note it down. I don't have a problem. You can tell me to pause. I'll pause it and you can jot it down. Okay. Offshore in the deep ocean, the difference in tides is usually less than 1.6 feet. The surf grows when it approaches a beach and the tide increases in bays and estuaries. This effect is amplified. In the Bay of Fundy, tides have a range of 44.6 feet. The higher tides in the world are at the Bay of Fundy in Nova Scotia, Canada. Okay? Okay, understood this knowledge? Okay. Because the Earth rotates on its axis, Moon completes one orbit in our sky every 25 hours, not to be confused with Moon's 27 day. Okay, if you look at it, look at this orbit around the Earth. Orbit around the Earth, we get 2 tidal peaks as well as 2 tidal troughs. These events are separated in 12 hours. Are you able to understand? Able to understand? Since the moon moves around the Earth, it is now not always in the same place, but the same tide, same time each day, so and so. The type of gravitational force that causes the Newton's law of gravitation. So every body in the universe attracts each other by a body with a force. This is already I told you, with a force which is directly proportional to the product of their mass and is inversely proportional to the square of the distance between them. The direction of force is along the line joining the centers of 2 bodies. These are all we have seen. M1, M2. Okay. The force is R or D, distance. Okay. Let 2 bodies A and B masses M and M2 are placed at a distance of R from each other. Let F be the force of attraction between the bodies. Then the force of attraction is directly proportional to the product of their masses. That is F proportional M1, M2. The force of attraction is inversely proportional to the square of distance between them, which means F proportional 1 by R square, or F proportional M1 into M2 R square, or F is equal to G M1 M2 R square. Now what is this G? What is this G?
Gravitational unit.
Constant. Okay.
Yeah.
6.673 into 10 raised to the power minus.
Wonderful. Where G is a constant called universal gravitational constant. Okay. Properties of gravitational force. Gravitational force is the weakest force in nature. What it happens? The gravitational force is the weakest force in nature. It is not the best force, or it is not the highest force available in the world. It is the weakest force in nature. As far as nature concerned, it is one of the weakest force. It is attractive force. Unlike electrostatics and magnetic force, they are both attractive and repulsive. But it is not a repulsion. There is no repulsion here. It is only an attractive force. Is there any repulsion? Repulsion mean by what? If you keep 2 magnets, North Pole and North Pole together, it repels. Am I right? If you take a magnet on left hand and right hand, and both the poles are north. Let's see, North Pole on left hand, North Pole on right hand. If you keep together, what happens? If you try to bring that magnet together, what happens? It repels. Am I right? Yes or no? But gravitational force is what actually here? It is an attractive force. ठीक है ना? Understood or not? Are you able to understand, my dears? Okay. It's a mutual force. First body attracts the second body, and the second body attracts the first body with equal force. Understood? Both attracts each together, each one to another. It is a central force acting on the line joining at the centers of the bodies. It is a central force. So someone is asking you, explain, if a question comes in your exam hall, the question is, explain gravity, okay, and explain gravity and explain gravitational force. These are you should write. You should write F is equal to G M1 M1 into M2 divided by R square. G is a constant value, or G is a universal constant. Okay, gravitational force is the weakest one. It is an attractive force. It is a mutual force. It is a central force. All these points you must write for getting a 3 marks or 5 marks. Are you all with me? Okay. Its mass and distance is dependent. The mass and the distance of gravitational force is dependent. Hope everyone are keeping the camera on. It obeys inverse square law. It obeys inverse square law. What is inverse square law? What is inverse square law? What can be? I'll give you an example. Let's see the intensity of the light to an observer. Okay. Suppose the intensity of a light to an observer. I'm talking about inverse square law. Inverse square law. Suppose the intensity of the light. Okay. Suppose the intensity of the light to an observer from a source is inversely proportional. Okay. To the square of the distance from the observer to the source. That is what? Nothing but inverse square law. The intensity of the radiation, okay, is inversely proportional to the square of distance. Would you like to write what is inverse square law? Himani, I can't see you.
So I'm just charging my laptop 1 second.
Would you like to write, Daksh, would you like to write a definition for inverse square law? Can ask in any exam. Explain inverse square law.
So what is it?
Inverse, this one, the last one, this point. See the cursor? Inverse square law. Okay? Shall I tell you, or I'll write and show you?
Yes, sir.
Okay, I will write and show you inverse square law. Okay. As of now, we keep it. After this slide, I will show you what is inverse square law. The long range force. It is a long range force. It decreases with distance as per inverse square law and becomes zero only at infinite distance, like electrostatics and magnetic force. So, would you like to write properties of gravitational force? Is there anyone in the class who wanted to write the properties of gravitational force?
We'll screenshot it.
Yeah, take screenshot. Taken? 3, 2, 1.
Done, sir.
Okay. So it does not depend on the medium between. So the 8th one also there. So you may kindly note it down. Take one more screenshot if required. So universal gravitational constant G. G is equal to F divided by, sorry, F, which is
Sir,
R
you
square
can
divided
take
by.
previous slide for a second. Thank you, sir.
Taken?
Yes, sir.
So universal gravitational constant, I told you the Newton meter square, how it has come. So either it is G is equal to F R square divided by M1 M2. Okay. G value is how much? 6.67 into 10 to the power minus 11 Newton meter square kg square. Can anybody tell me in this class how Newton meter square and kg square has come as SI unit of gravitational constant?
So force Newton, then
Force into R square divided by M into M2. So
yeah,
force into force SI unit of force is Newton,
Newton.
and R square is meter. That is radians is meter. Am I right? Radians is meter. M1 into M2 mass, 2 masses kg square. Is that clear? Is that clear? Okay. The value G does not depend on the medium between two bodies. So G is constant. It doesn't have anything to do the between two masses. Okay, G is constant. The value of G is constant, and there is nothing to do. It has nothing to do the force or the attraction between two objects, object 1 and object 2. The value G is same throughout the universe, and hence the name. Universal gravitational constant G is different from acceleration due to gravity. Therefore, correct symbol must be used accordingly. Big G, small g and big G. So what is small g? What is small g in
Gravity.
physics? Gravitation, acceleration due to gravity. Small g denotes small g in physics. Listen. So in physics, small g denotes acceleration due to gravity. Big G denotes what? Capital letter G denotes
Gravitational constant.
gravitational constant. SI unit of G is Newton meter square kg square. If two bodies of mass 1 kg each are separated by 1 m from each other, then G is equal to F. Therefore, universal gravitational constant G is numerically equal to the force of gravitation which exists between two bodies of unit masses kept at a unit distance from each other. Now you understand why G is there and what is the difference between G and force. If two bodies of mass 1 kg each are separated by 1 mass from each other, because using 1 mass in two bodies of mass is separated by 1 mass, okay, using 1 mass, then G is equal to F. G is equal to force. Okay. Therefore, universal gravitational force G is numerically equal to the force of gravitation which exists between two bodies of unit masses kept at a unit distance from each other. Gravitational force is the weakest force of all. If two bodies of mass 1 kg each are separated by 1 mass from each other. Okay? Are you able to understand this point? Then F is equal to G, 6.67 into 10 to the power minus 11 Newton. Though various objects on this earth attracts each other consistently, they are not, they do not visible. I mean, they do not cause any visible motion because the gravitational force of attraction between them is very, very small. As far as Newton concerned, you keep two objects, object 1, and if you take another object, okay, two objects, let's see two objects. These two objects, between these two objects, there is an unbalanced force, but that force is very minimal. That is why we are not able to see that force. Otherwise, always there is a force between two objects. Okay? Yes or no? Imagine a situation on the earth if the objects continuously move towards each other due to gravitational force between them. What will happen? Accidents everywhere. By this time, earth will not be there. Am I right, my dear? Hey, car and car will hit, bus and bus will hit, human and human will hit, cycle and cycle will hit. Am I right? Yes or no? Everything will hit. Can you move anywhere? Can you move anywhere? No, na? No. So that only gravitational force is very minimal. Very minimal. We haven't found out any planet so far where gravitational force is very huge. Did we find anything? No. When both objects are very big, having very large masses, then the gravitational force of attraction between them becomes extremely large. Understood this point? Okay. The gravitational force due to Earth on an object of mass 1 kg placed on the ground is 9.8 Newton. Okay. Did we see that? Okay, correct. So gravitational force between Earth and Moon, even at a large distance, is very large, and it is 2 into 10 to the power 20 Newton. What is the gravitational force between the Earth and Moon? The value is how much? 2 into 10 to the power 20 Newton. Remember this. This will come in numerical. Okay. Numerical will be asked based on this. Gravity, this chapter is got a lot of numerical problems. After I complete my theory part and explanation of concept part, we will move on to, we will be moving to the numericals. This has got a number of numericals, this chapter. So there, these values and all will be asked. If you want to point it or take a screenshot. 2 into 10 to the power 20. What is the gravitational force? The value of gravitational force between Earth and Moon is what actually? 2 into 10 to the power 20 Newton. Is it clear now? So we have reached till this point. Kepler's laws of planetary motion. Is that clear? Okay.
Yes.
Now Kepler's law of planetary motion, we will have a basic understanding of this from presentation, then I'll come to the notes. Okay. Let us see. First law of orbits. First law of orbits. What is this orbits, by the way? What is this orbits, Himani? Earth revolve the sun in an orbit, like any other planet. Am I right? So orbit come from there. An atom, is there any orbit between atom, nucleus, and proton, neutron, and all? Is there any orbit? Is there any orbit?
Yes.
So what
Electron
is the
around
yeah, there is a what are the first shell, second shell, and third shell, and all? It goes right. So something is there. So orbit. I'm not going to chemistry now. So orbit is understood now. So orbit is there. Every planet moves around the sun in elliptical orbit with the sun at one of the foci of the elliptical orbit. Now here what happens? What is elliptical orbit? Have you ever observed the shape of the orbit? Is it a round?
No,
Is it a
sir.
pure square? Sorry, is it a pure circle?
No, sir.
It's a kind of oval shape or little more larger than the oval shape, little
Larger than oval.
extended, like little more extended from the orbit shape. Sorry, from the oval shape. Am I right? Am I right, my dears? So orbit. Now the picture of orbit should come to your brain now. Okay. What is foci here? What is foci? F-O-C-I, foci. What is focus? What is focus? Focus on a particular activity. Focus, concentration. Okay, concentrate. Focus. Focus on a particular activity. Focus on a particular center. So you focus. The plural of focus is foci. What is that? If I say you have foci, foci means you are concentrated on two things now. One is the friend sitting nearby you. Second one is me. Right? So you are with the two foci or focus. Are you with foci or focus? Are you with focus or foci? Okay? Chalo, you understood now. So foci is the plural of focus. What I'm telling, every planet who is rounding or revolving the sun in an orbit having two center of focus. My dears, understood now? Kepler's first law says, what it says? Kepler's first law. Please remember, there will be a question asking, explain Kepler's law of planetary motion. There are two laws which will come. First law is here. What the first law says? Every planet moves around the sun in an elliptical orbit with the sun at one of the foci of the elliptical orbit. Which means if you are taking a circle, in a circle there is only one center. Which means any object revolving the circle. Okay, suppose you take a small ball and you tie that ball into a rope. Now, rotate that ball keeping the string on other side of the string on your hand. Okay, rotate the ball in circular motion. Where will be the center of focus? Where will be the center of focus of the ball? You understood my example? You are tying a ball, rubber ball, take a small rubber ball, tie that rubber ball into a small string and hold this string, the other side of the string you hold it and rotate this in circular motion. Okay, when you rotate it in circular motion, as far as this circular motion concerned, where will be the focus of the ball? The center of focus of the ball will be towards your
Would
hand.
be the string, yeah, the hand which is holding the string.
The hand. But here the planets are in an orbit. It is not in center. It is not in a round. It is on the orbit. And because it is on the orbit, it focuses to center. Now slowly we are coming into why planets are not colliding, my dear. Okay? Why planets are not going to collide. After you understanding this Kepler's law of planetary motion, you will get to know why planets are not colliding. You got me? Okay? So, see this. Okay? See the orbit. Are you able to see the orbit?
Yes,
Are you able to see the orbit?
Yes,
Okay.
Yes, sir.
See this orbit, shape of the orbit. See the orbit. See the two center, F1, F2. Now, do you think that where Earth is actually focused? Is it in F1 or F2? Can't say.
yes,
Can't say because two focus is called foci. Two focus is called foci.
Okay.
Foci. Foci means two focus, and that is happens only on elliptical orbit. And foci will also happen to us when we are in class. Right? Two center of focus. One is a teacher, another one is a friend sitting nearby. Am I right? So two center of focus. Who were actually focused. ठीक है ना? So first law understood, Kepler's first law.
Yes, sir.
How many of you clear with me? Is it okay? Second law, we'll learn in the next class. It is little bigger. First law of Kepler, I have stopped in gravitation class. We have learned what and all we have learned today's class. Who can tell me what and all we have learned in today's class?
We learned about the universal constant of gravity.
Ritika, I can't see you, my dear.
The formula.
Yeah, universal constant we have learned. We learned gravity and gravitation.
We
Am I
learned the
right?
formula m1 m2 upon d.
Wonderful. We have learned the value of G. What is G value? 6.67 into 10 to the power minus 11. Don't forget this in your life. 6.666 point. How much it is? How much it is?
6, 7.
6.67 into 10 to the
minus
power
11.
minus 11.
11.
Then what we learned? Three theories. Three
three
theories.
theories.
Okay. Then I will ask Avantika. Avantika, let me understand what is heliocentric theory. No one should tell her. Avantika, what is heliocentric theory? Heliocentric theory. Heliocentric theory. Okay.
The
Avantika is
sun
not
is in the center and the
Ah.
planets move around.
Who found it?
Who found?
I wanted to ask Aditya who found it. Aditya, who found it? Is Aditya
Sir,
there?
Nicholas Copernicus.
Very good. Nicholas Copernicus. What is geocentric theory?
Which Earth is in the center and everything revolves around.
What is Ptolemy? told me, sorry, look, no, Tychonic system.
Moon is in the center and everything.
Okay. Who cleared all this and said like
Galileo.
Galileo. ठीक है ना? That we have learned. Am I right? Yes or no? So clear. So today's class is it clear till Kepler's first law of planetary motion we have learned.
Okay.
ठीक है ना? Next class after completion of Kepler's second law of planetary motion we have to do few numericals based on the first part of gravitation.
Thank you, sir.
All the best. Take care. Till I see you next. Keep your health fit. Eat properly. Enjoy. Study well.
Thank you.
Okay. All the best.
Bye, sir. Thank you,
Bye.
sir.
Bye. Bye.
Bye, sir. Thank you.
Bye. Thank you.
Bye, sir. Thank you, sir.
Bye. Say.